All right, on to the next video here. Number 11 on that review says Jamie and Michael are rewriting this expression, x squared plus 100, in a factored form. Well, first of all, if you go back to that last video, we just talked about how if I have an x squared term and a constant term, at minimum, I have to have two sets of parentheses, right? I have to have like a x plus a number, x minus a number. They don't have to, actually no, they have to be the same number. They have to be the same number because I'm getting rid of the x term in the middle. There is no x term, there's an x squared term and a constant. So, I mean, just going off of that, I know that this cannot be drawn as x plus 25 and x plus 4 because I know that those numbers have to be the same and one of them has to have a negative sign. That's the only way to get an x squared term and a constant term. The second thing though, and this is where Michael actually comes in being right. I mean, Jamie's flat out wrong. You will not get x squared plus 100 if you distribute that x 25, this one here. But Michael is correct. It is not possible because remember again, when I do this parentheses deal, I have x plus and x minus some number. So let's say I did 10 and 10. The reason I do 10 is, 10 times negative 10 is at least 100, but it's not negative. But the other thing is x times negative 10, x times positive 10. This will at least give me x squared and a constant term. The problem is the constant term is negative. So it is actually impossible to get an x squared and a plus 100, like a plus number at the end, or a positive number, because we have to do this difference of squares where one sign's negative. So in the end, Michael is right. It is not possible. You cannot do that such that you end with a positive constant term. Moving on. Number 12. Number 12 says, below, here are some equations. Determine how many solutions. Well, a solution would be, oh man, the easiest way to describe how many solutions does it show? Well, a solution is referring to how many zeros there are. All right, so if the graph has solutions state what they are, well, a solution is really where, if I plug in x, I would get 0 out in the y. So, in other words, if I plug in 3, let's look at B, it's the best example we have. If I plug in 3 for x, I get 0 for y. So, if I had y equals x squared plus 2x plus 4, I don't know, whatever it is, right? What's going to happen is if I plug in 3 for all my x's here, I should get 0 out on the other side. And that's what's happening, right? We're trying to take the graph and identify where does that happen. So how many solutions do you have is really asking how many times does the graph of the parabola cross the x-axis. So B, the answer is 2. A actually comes down. Does it cross it? Not directly, but it does make a true statement for 0. If I plug in 1 for x, I still get 0 for y. So how many times does it happen here? Well, it only happens once. So my answer to this question is there's one solution. One time I can plug in an x and get a 0 out for y. Here I can plug in x at 3 and negative 2 and get my answers to be 0. C, what's interesting about C here is we'll never cross the x-axis. We won't even touch the x-axis. This one, we would say, has no solutions in the real number system. We are not ready to talk about imaginary numbers. But if we did, we would say there are 2 answers. But the thing is, we don't cross or touch the x-axis, so the answer is there are no solutions. So going back, what are the solutions? Well, the number of solutions here is 1. So what is it? My answer is x equals 1. Okay, the solution is asking what value of x do we put in to get a 0 out? Okay, well, so x equals 1, that it gives me a 0. Okay, so b over here, I said if I plug in 3 for x, I should get 0. Okay, so that means x equals 3 is a solution. If I plugged in -2 into my equation, -2 comma 0, I should get 0 in my equation. So x is -2 is my other solution. So hopefully that is, at least clear as mud. But again, going back to determining how many solutions really comes down to how many times does it touch or cross the x-axis. That number correlates directly to the number of solutions. Okay, moving on. 13. Okay. Sorry, I kind of blocked that a little bit. 13 has a quadratic function, x minus 4x plus 2. So when they ask for the x-intercepts, remember, graphically, an x-intercept is, right, it's along the x-axis. Well, what that means graphically also, though, is, that means that whatever I plugged in for x, I got a 0 out in the y direction. So if I have y is equal to this x minus 4x plus 2, the x-intercepts happen when y is 0. So I'm going to set 0 as x minus 4 times x plus 2. Well, how do I get 0? How do I know what to plug in here so that this whole mess becomes 0? It's really simple when we have it in factored form. If I have it in factored form, I know that if I chose 4 as an answer, so just so you know, one answer is x equals 4. Why do I know that? Because if I said x is 4, I plug it in here, x minus 4 is 4 minus 4. That's 0 times, well, x is here, so 4 plus 2 is 6. 0 times 6 is still 0. So one intercept is at x equals 4, because the intercept is when it crosses the x-axis. The other 0 happens if I were to reverse this and say, well, I don't care about the first parentheses. I want to know if I can make the second parentheses 0, then that 0 times anything is 0. So now x is -2. That's my other answer. See, because if I plug in -2 minus 4, I get -6. But if I do that times -2 plus 2 here, that's 0. And that gives me another 0. So those are my answers to the x-intercepts. Okay. The other thing then that asks 13 is asking, 13 says, what are the y-intercepts? Okay, well, again, graphically, let me erase that stuff. Graphically, the y-intercept is where do I cross the y-axis? Well, that's even easier than the x-intercept, because in the y-intercept, all I'm doing is if I plug in 0 for x in my equation, I can, super easy, right? So 0 minus 4 times 0 plus 2. So I've plugged in 0. What value do I get out? That's where I cross the y-axis. So 0 minus 4, that's -4 times 2, so that's -8. So at y equals -8 is my y-intercept. So graphically, I can see if I plug in 0, I go down to -8. That's where my parabola crosses the y-axis. It doesn't mean it's like the vertex or anything. It just means that's where the graph crossed the y-axis. So there you go. We made it through several. Nice. All right. So yeah, what was that? 11, 12, 13? Cool. All right. Hopefully we can finish this out in one more video, guys. So hang in there.